5.4, bullet hits wood block. It is on page 165, continues on to 166, and it reads, a 0.020 kilogram bullet traveling horizontally at 250 meters per second embeds in a 1 kilogram or 1.0 kilogram block of wood resting on a table. Determine the speed of the bullet and wood block together immediately after the bullet embeds in the block. So the first thing we're going to want is some sort of a sketch with a before and after situation. So on the left is my before situation. I've got a bullet approaching a wooden block. One of the things that we're going to be looking for is velocity of the bullet initially. Velocity is a vector, and the block has no velocity at the beginning. We've got mass of our bullet. We're going to use B for bullet and W for wooden block because they both start with B. Mass of the bullet was 0.020 kilograms. Our velocity of our bullet initially in that X direction was given in the problem as 250 meters per second. Since I have it going to the right, I'll call that a positive 250 meters per second. As far as our wood block, our mass of our wood, thanks, is 1.0 kilograms. And our velocity of our wood, is just 0. It's not moving. It's not moving at all. And I've defined the system here as the block bullet system. Afterwards, we've got our velocity of block plus wood final. What we're wondering about is what that is. Velocity of our block plus our wood final in the X direction. That's a lot of abbreviating. To help us understand this, we can draw one of those impulse momentum bar charts. I'm going to scroll down. I'm going to write our situational stuff. We've got the momentum of our box, or not box, that's bullet initially in the X direction. We're going to have the momentum of our wood initially in the X direction. There might be some sort of a impulse in the X direction. We're going to have the momentum of the bullet final in the X direction and the momentum of the wood block final in the X direction. I'm going to put some sort of an axis here. Oh man, that went all wonky. And this level can be 0. This can be positive. I'll make a bar that represents the momentum of the bullet initially. Oh boy. I want it to be more of a rectangle. My bad. Let's say the bullet's got a lot of momentum. It's moving pretty fast. The wood block has no momentum at all. Because there is no forces outside of our system, there is no impulse in this situation. I might even try to make this look a little nicer by doing this. whatever momentum we had before is going to be the same momentum afterward, except for now the wood block's going to get some of that momentum and the bullet's going to have some. But the bullet and the block are going to be stuck together. If they're stuck together, they have the same velocity. The only difference between them will be the mass. So more mass will be given to that wood block. So let's say the wood block's this much shorter than the bullet. I'll make the bullet's bar graph a little smaller. I should have made that a little different. Let's go. Oh man. Oh man. And then a little one here. So now that we've represented the momentum before and after and the impulse with our bar graphs, we should represent them algebraically. Our momentum of the bullet before would be mass of that bullet times velocity of that bullet initially in the x direction, plus the mass of the wood times the velocity of the wood, but the wood has no velocity at the beginning of this problem, so that's 0. We'll have to consider any sort of impulse that happened in the x direction being equal to the mass of the bullet afterwards and the velocity of now the bullet plus the wood final in the x direction. There's a lot there. Plus the mass of the wood and velocity of the bullet plus the wood final in the x direction. Besides the wood and the block, we know of no external forces, so our impulse ends up being 0 as well. So the equation that we end up with is mass of block, velocity of block, initially in the x direction is equal to this stuff. Mass of block, velocity of block, and wood, final in the x direction, plus mass of wood, velocity of bullet plus wood, final in the x direction. So many letters. Since we are interested in the velocity of that block, that's what we're going to solve for. One thing that we can see is that both these terms have velocity of block plus wood final in the x direction, meaning that you can, what's the term when you pull it out? Factor it out. Mass of block plus mass of wood. Both of those things are going to be times velocity of block plus wood final in the x direction, which means I have to write less letters, which makes me happy. This is still on the left. We still want to get the velocity by itself, so I would divide by mass of block plus mass of wood on both sides. Mass of bullet plus mass of wood. Meaning, this would cancel. So, to find the velocity of the bullet and the wood, final, in the x direction, we would need all this stuff. Mass of block, initial velocity, and those masses. When we have all that. So we can say mass of block was 0.020 kilograms times velocity of bullet initial was 250 meters per second over the mass of the bullet plus the mass of the wood, 0.020 plus 1.0, and those are both in kilograms. Or you could just say 1.020 kilograms. That's going to equal the velocity of your bullet plus your wood final in the x direction. You end up with an answer of positive 4.9 meters per second. And this should make sense because the bullet was coming from the left. It had a positive velocity. the bullet and wood block will continue to move to the right. So it would be in the positive direction, and this is what's actually done in ballistics to test energies that bullets have in travel.